Hello, this video shows processing of APUS UAV LiDAR point cloud using TerraScan wizard. The dataset I'm going to use has been flown at 90-meter altitude above ground, and it's simply called vegetation. So I start the wizard, I select the scanner system as being APUS UAV LiDAR, I select a point cloud file or multiple point cloud files, and I select a trajectory solution or multiple trajectory solution files. The incoming LAS is in projection system 4547, and that's the projection system in which I'm going to process the data. And I will let the elevations stay as ellipsoidal. This was the import step. The software has read in 114 million points, and I want to get a little bit familiar with the points. I look at the point cloud colors. So the system has given us a colored point cloud where points have been colored from the camera images. I can see that there's a lot of trees, there's a few buildings, there's one road, one major road. Not really cars, a few moving cars, but not a big number of parked cars. I checked the point cloud density. That's 180 points per square meter. The import brought in the trajectory solution, and it's now one trajectory solution in TerraScan. The processing I can do with a wizard, and the wizard steps. Okay, so first I take a look at the point cloud as one big cross section to see if there's any points above the ground or below the ground. And then I start doing processing steps. I can do all the steps in one go, but for the purposes of demo, I will do one step at a time and explain what the software has done. First step was splitting trajectories. So now instead of one trajectory, we have 9 trajectories, the individual passes of data collection over the site. And points have been assigned line numbering, which gives me the ability that I can check how well flight passes match each other. Do I need to do improvement of the positioning by matching flight passes to each other? I look at a cross section along the road. The blue and the green line passes look like they are giving me the same surface. No evidence of a mismatch between flight passes here. I look at another spot on the road. There's altogether 4 flight passes overlapping here, and things are looking quite good. I try to look at some sloped surfaces as well, so that I verify that there are no XY mismatches. And things are matching quite nicely. Another building, I check. There's a wall surface, and that looks like it's matching nicely as well. So I don't need to do matching, so match passes I can skip. The dataset is matching nicely. But I do cut overlap, and that removes overlapping data. In the beginning I have 114 million points, and this will reduce the size of the point cloud to 66 million. The edges of the flight passes have been removed. So now at one XY spot we typically have data from one flight pass only. By removing the edges we have removed the less accurate data, and so our dataset has become smaller in volume, more uniform point density, and more accurate. The next step is smoothing, and I do a cross section of a road surface so that the effect of smoothing can be seen. The default settings for smoothing are such that we only do smoothing where the point cloud is not green. So we do not modify the X-Y set in the grass, vegetation areas. We only modify that in non-green places. And so now there's less point-to-point noise visible in the point cloud. The road surface looks nicer in a cross section. The next step, which is optional, is for speed. If I want to speed the processing up, I may do thinning. The thinning classifies some of the points into an inactive class. It has left 24.8 million points in the active class and 40 million and 200,000 in the inactive class. And so I don't use all the points to decide what is ground, what is tree, what is building roof. I use just the points which are now visible in view number 2. The next step is ground classification. And the ground classification is one of the key steps in processing. And because ground is an important end product, I typically do checking of the ground classification by creating a triangulated model of the ground and displaying it as a shaded surface. So ground classification is done. I go to create editable model and I create a triangulated model. And I use display shaded surface to display the triangulated surface. I can use other display tools, but shaded surface is the one that I most often go for. I hide the point classes so that in view number 1 I'm looking at the surface model. And I try to see if there's anything that stands out as strange looking. And here I do a cross section of the spot. I display class coloring in the cross section, and then I decide that yes, I want to take those points out. So I classify the points as low point and the shaded surface is updated. In this way I would look for anything which does not look right in the triangulated surface model. And here we have either a terrain feature or a bridge. And I decide that it is really a terrain feature. I want to include more points into the ground surface in this area. I would draw polygons for all those places where I see the same need that I want to add data to the ground surface. I would show the relevant point classes in view number 1 and then run classify ground inside fence only, making the iteration angle now bigger so that the software will more easily classify points as ground. I hide the point classes and then I update the triangulated model with rebuild editable model to reflect the changes done by the automatic classification. And now the ground model looks better and I'm happy with that spot. And in reality I would continue with the ground checking process for a longer time, but now we will proceed and I remove the triangulated model and I move to the next step in the wizard. Classify height from ground simply classifies points into low, medium and high vegetation. High vegetation is points 2 meters or higher above the ground. And these are the points in the high vegetation classes. The medium and high vegetation points I do want to classify further into a number of classes. I don't think there's really cars, a significant number of cars in this dataset. I take that off. I now also do the copying the result to the inactive points and copying the result to the noise points. This recording has been speeded up. The classifying above ground step takes a significant amount of time, but in the recording I've cut out the time when I wait for the computer. So now we have a classification of above ground features done. This is the set of points classified as hits on trees. This is the set of points classified as building roofs. Building roofs have related classes done: roof structure, wall structure, and that's what the result looks like. I also have some points classified as poles. And I show one cross section so that you see what the pole points look like. And it's the pink-like color which are the points classified as pole. So I have done basic classification of the point cloud. I may want to save the classified point cloud now, and I'll save it as an LAS file with name vegetation classified.las. Thank you for watching.